Hello everyone, this is my first video of ETO preparation series. Let's start. Today we are going to discuss about the PN junction diode. What is this PN junction diode? The definition of this PN junction diode is, it is a foundational two-terminal semiconductor device that allows electric current to flow in only one direction. That means, let's get into it. This is called the PN junction diode. This PN junction diode is a pure semiconductor material like silicon crystal. Okay. Before understanding this concept, we have to know about this P and N type regions. This is P type region. This is N type region. In P type regions we are having holes. In N type regions we are having electrons. We are adding the pentavalent impurities in this region, so it is called an N-type region or N-type semiconductor we can call. Here in this P-type region we were adding trivalent impurities, so it is called a P-type region or P-type semiconductor. In this P-type region, the majority charge carriers are holes, the minority charge carriers are electrons. Same as in this N-type region, the majority charge carriers are electrons, the minority charge carriers are holes. Here we are combining these two separate regions, P region and N region. We are combining to form a PN junction diode. Let's know about how this depletion region is formed. That means this place which we are seeing it consists of no charges, it is neutral. When these p-type holes are moving this side and this n-type electrons are moving this side, we will get into a region called this depletion region. Okay, what will happen in this depletion region? These two regions, these two opposite charges will form a potential difference in this region. The potential difference is called as barrier potential difference. Let's see how it formed. What happens after these two charges coming into this region? Let's see. Okay. After both charges coming in between the depletion region, the charges will diffuse and the potential difference will create. The potential difference will stop the diffusing for next moving charges. After formation of this potential difference will stop the diffusion in between this region and it will start allowing the other charges to flow in between. We can represent like this. This is a p-type material, n-type material. This is called depletion region. This is the symbol of this PN junction diode or a diode. This is the anode side and this is the cathode side. This is called the we can see these diodes in the market in this form. We can see in our labs. This strip mark represents the cathode side and this is anode side. Here we are having the two junctions, forward bias PN junction and reverse bias junction. Let's get to know about what is forward bias PN junction. This is power supply, the positive to the P side and the negative to the N side. In this forward bias, the positive charges flow through this P-type region. When the positive charges come to this region, here the holes will repel and it will take the direction towards this depletion region. Same as the negative charges flows towards this N-type region and it will repel with electrons and it will move towards this depletion region. What happens after this function is Yeah, after moving these electrons and holes towards this deflection region, the deflection region's thickness will reduce because the both charges direction is towards this deflection region. So the thickness of this region will decrease, and we can see here. Now after moving the holes and electrons towards this deflection region, the thickness of the deflection region decreases and the current will flow. Why? Because this region of here it offers low resistance, because when the current is moving properly, we should think that the resistance is low in that area. So this is called the forward bias PN junction. In reverse bias PN junction, the difference is here we will connect the negative side, like we will connect the negative side to the P type region and the positive side to the N type region. Yeah, once we connect like this, what will happen is the holes will move opposite to the deflection layer, and electrons also opposes from the deflection layer. As a result, what we will get is the thickness of this deflection layer increases. What happens if it increases? It won't allow the current to flow in between. Here it will having the high resistance. So in this bias, due to minority charge carriers, the some amount of current will flow between this region. What we will call this flowing of little current is called leakage current. Let's get to know about this V1 characteristics curve of PN junction diode. By looking at this graph, it is very simple to understand. This is y-axis, this is x-axis. X-axis we will represent it as voltage. In y-axis we will represent it as current. This is the direction of forward bias. In forward bias we know that current will flow. So this is the direction for this flowing of current in forward bias. And in reverse bias there will be no current. So in this graph we will represented this reverse bias in this direction. We know that in reverse bias some amount of current will flow. In this curve PN junction diode, we will say that breakdown voltage. How this breakdown voltage will form is by breaking all covalent bonds. It will form a small amount of current. Yeah, this is all about the PN junction diode. If you like this video, please like and subscribe.